In this video, I'm going to show how to prep data for a transformer. The transformer is the T in ChatGPT. Here is the text, hello world. This is used for training in this case. It could be like 1,000,000 characters of Shakespeare or any other text. This is the context window. Here's the vocabulary, which is all of the unique characters in hello world. HELO space WRD. It will get rid of the extra L, that other extra L, the extra O. The vocabulary passes the text, the hello world, into the set function, which gets rid of duplicates. The sorted sorts in alphabetical order, but it places the space at the beginning. And then the rest of these are in alphabetical order, the DEHLORW. And those are the unique characters from hello world. So the unique function, it outputs the list of unique characters. Next is the tokenizer, or the encoder, which converts the string to the index, or the characters to the integer ID. So what this will do is taking the letter E, and it'll pass it into this S to I function, or string to int function. It will enumerate the output of the unique text, and remember the output of the unique is this. So enumerating it, the I right here, for I, comma, char, and enumerate, I will be the index location starting at 0. So 0, 1, 2, 3, 4, 5, 6, and 7. And the char will be the actual values in that location. The space DEHLORW. As this iterates through, as you can see here, this is a dictionary. So this is creating a key value pair. This is indexing with the character as the key, and the value is the index location. So whenever a character is passed in, such as the letter E, this dictionary is indexing at E as the key, and the value is the index location from here. So if I put in E, then if I look up here, 0, 1, 2, index location 2 is where E is. So that becomes his ID number. So I put in E, and it should pop out with 2. And look out here, and it comes out with 2. Down here, instead of putting in one character at a time, I can loop through whatever text is placed in there. If I put WRD, then it'll iterate through, and this loop will take the W, and it'll put it into the S to I, and then it'll output the 0, 1, 2, 3, 4, 5, 6, 7. It'll output 7 as the ID for that. Then it'll go to the next character in word, which is O, and that will go into the S to I, which is here. And so it'll output 0, 1, 2, 3, 4, 5. So it'll output 5 for that, and so on. So it'll be 7, 5, and then whatever the other two are. So if I look down here, after I run it, yep, 7, 5, and the other two are 6, 1. So that's the ID numbers in this example representing the word. What's next is we can take these ID numbers and use them to look up a embedding vector, which is the representation for each character. And in this case, it comes out to 2,880 floating point numbers. Here's the embedding. And so it's taking the unique text, the length of that, and it's going to create a basically sort of like a list of 2,880 numbers for each character. Like if I put in the letter E, for example, and it converts it to a number which was 2 up there, then it would grab index location 2. Just say like for the word there. Well, actually, for the hello world, the unique characters from that, each one of them has a list of numbers, 2,880 numbers representing its meaning. Like, for example, the first part could mean how much of a vowel it is. If it's a high number, then that would indicate it's close to a vowel, for example. Such as the letter A would have a really high number, but the letter Y would have a decently high number, because A, E, I, O, U, and sometimes Y. So just say the letter E has 2,880 numbers, sort of like this, representing it. And each of these things represents part of the meaning of E. It's more complex than that in reality because there's things called polysemantic neurons, which mean that each of these can have multiple meanings to them. Like this section could have several different meanings to it, like how much of a vowel it is and how close to the beginning of the alphabet it is, and if it's with the positional encoding and stuff we'll talk about later. The letter E, so you know stuff starts at index location 0, so 0, 1, 2. Picture a whole bunch of these. Each one of these is a row and there's a bunch of rows. Blank space is index ID 0 and it's for this specific vector. D is index location 1 or ID 1, and that ID 1 grabs this specific vector. And then E is index location 2 or ID 2, and that grabs index location 2. And so that's how that works for the embedding matrix. So this is what this is talking about, is remember the unique text is the letters have been going back to over and over, these. And there are 1, 2, 3, 4, 5, 6, 7, 8 of them. 0, index location 0 to 7. The length of that is 8. So it creates things like this, but it'll create 8 of them. Each one of them has 2,880 numbers in it, sort of like this. Except they're random numbers, and the numbers would likely be different for each one. And they get trained later so that they match the meanings better. And the way it trains is it'll compare it to what the answer should be later, the next token prediction, and then it'll make adjustments using derivatives and using derivatives to figure out how much to make adjustments in what direction, and then it'll do that with the updates to change each of these numbers so that they have the correct meanings for the correct characters. And so next, go down here to positional encoding, which once it's trained, it basically keeps stuff in order is one of the big things. Like put in the word cat, for example. It would say, okay, the beginning character here is C, the next one's A, and the next one's T. So it would number them, 0, 1, 2. And that's one way to conceptualize what the positional encoding does. And this is the embedding for the multiple characters. And look here's a tensor, and that's 3 characters, and that was for the wow that I've typed in close to the top. This was an example output for wow. The W could be represented by that vector, the O represented by that, and the next W represented by that. The reason this W and this W are different partly is because the positional encoding, because it could say that this W comes after a O, but this W doesn't come after a O, it comes before a O, and it's the beginning of the character sequence. So now you have the embeddings and the positional encoding added to it, and it adds element-wise. So you say the embedding and the positional encoding, and each of these is 2,880 numbers. Like, see, the POS is 2,880 numbers. So it'll add the vectors element-wise, which means like it'll add the first thing in the EMB with the first thing in the POS and make a new vector with the result of that. Then it'll add the second thing in the EMB with the second thing in the POS, and it'll put that result as the second thing in that new vector, etc. And what the torch.stack does is, notice right here, this is an actual list. It's not a torch tensor. So it's creating a list of tensors. So what torch.stack does is it converts the list of tensors into a tensor containing multiple rows or vectors. In other words, it turns it into a matrix. instead of just being a list of tensors. A tensor is a specific data type that can be a vector. If I understood it right, it can be a vector, a matrix. A vector is a single dimension. A matrix is 2 dimensions, or it could be 3 dimensions, 4 dimensions, etc. And that would be considered a tensor. All of those would. So the stack converts this list of tensors into one tensor of tensors. It would say something like tensor, and then here it would say tensor, and then it would have this row. And here it would say tensor and have this row, and it would say tensor and have this row. But the stack stacks them like this, so it's a single tensor of 2 dimensions. Or this is how to prep the data for going into a transformer. I have other videos you can check out that talk more about how transformers work, and Andre Karpathy is a good resource to look up. His channel, he teaches in detail about how transformers work. He's one of the creators of ChatGPT, so he knows what he's talking about. If you have any questions or comments, let me know, and thanks for watching. Please click like and subscribe.